In this video we're going to look at how to solve quadratic trigonometric equations. So we're going to treat this in much the same way as we have done for previous quadratic equations, in terms of I'm going to make it equal to 0, I'm going to attempt to factorise, or if not, complete the square. I'm going to find my solutions. And the difference here is once I've got my solutions, they're going to be in terms of either cosine x or sine x or tan x or whatever. And then I'm going to have to find the solutions looking at the range. Now this one is got a sort of added level of complexity because part of it is in terms of cosine and part in terms of sine. So I'm going to deal with that first, and I'm going to deal with it using the identity that sine squared x plus cosine squared of x is equal to 1. And therefore that cosine squared x is 1 minus sine squared x. So if I stick that into the original, I can say that 1 minus sine squared x minus 6x is equal to 5, and then I'm going to collect terms together on one side, so it's equal to 0, and I want the sine squared x to be positive, so I'm going to move everything to the right hand side, but for ease of use I'm going to write it on the left side, and that gives me this. And I don't fancy really trying to solve that at the moment, so I'm going to use a substitution to help me. I'm just going to say, well, let's let y be equal to sine x for the minute. Okay. So now that just becomes y squared plus 6y plus 4 equals 0, and that's a lot easier. I'm more familiar with that. So let's go for it. So y plus 3 squared, subtract 9, add 4 equals 0. So I'm going for completing the square here, so y plus 3 squared equals 5, y plus 3 equals positive or negative root 5, so y equals negative 3, add or subtract root 5. So they're my solutions for y. So let's look at it for x then. So, well, y is equal to sine x, so we've now got sine x equals negative 3, add root 5, or sine x equals negative 3, subtract root 5. Now values for sine x must lie between 1 and negative 1, so this has no solutions because this is going to be negative 5 point something. This one does, because that's going to be, well, root 5 is 2 and a bit, so it's going to be about negative 0 point something. So this does have solutions. So let's do arc sine of negative 3 plus root 5, and this is going to give me a value for x. So I've got it in radians mode, that's good. So I'm going to do arc sine of negative 3 plus root 5, and that gives me a negative 0.869. Now it's worth noting that this solution isn't in the interval that we were given originally, and for dealing with this we actually want it to be just the size of the angle that's important rather than the sine here, so I'm just going to multiply it by negative 1 just so that I get a positive angle, but it's the same magnitude, and I'm going to store it into memory A for the moment so I can deal with it later. And now I'm going to draw in an angle diagram, and I'm going to mark on which quadrants are positive, or sorry, which ratios are positive in which quadrants. So my solution here is negative, sorry, move that up, right, negative 0.869, so that's going to be down here somewhere. And where else is sine negative? Well, that's down here. So here we're looking at a 0.869 degree angle as well, but we're interested in solutions from 0 to 2 pi. So 0, this is pi by 2, pi, 3 pi by 2, and 2 pi. So within a complete revolution, we're going to get this solution here, which is pi plus 0.689, 869. So x equals pi plus 0.869 is one solution, and my other solution is this one over here, which is 0.869 before 2 pi. So this is 2 pi subtract 0.869. So now I'm going to go to my calculator and I'm going to do pi plus my stored angle, which was 4.01, and then 2 pi subtract my stored angle, which is 5.41, and here I have my two solutions for x within the range that was specified.